Hello, Professor. This is my final project presentation. The project I chose is a Kaggle contest named Home Credit Default Risk. Firstly, I will briefly introduce the background of the project. Many people struggle to get loans due to insufficient or non-existent credit histories. And unfortunately, this population is often taken advantage of by untrustworthy lenders. This poses a huge danger of crime. Home credit companies try to solve this issue by making use of a variety of alternative data. Here, to help to unlock the full potential of data and make a better prediction of possible default people, I use different statistical and machine learning methods to achieve this goal. Then, I will introduce the data I used in this project and explore the structure of the dataset. The main data file I used in this project is the application train.csv file, which contains 122 variables and around 300k observations. Other files also contain several other information, but due to the huge amount of the number of observations and information in the main data file, I decided to pay more attention to the main file and those 122 variables. The variable can be roughly divided into several parts of features: personal information, loan information, documents provided, and information from bureau. Generally speaking, this is a supervised learning classification problem that contains training data points and relevant category labels. For given user data, we use to predict the category labels associated with that client. And this is binary classification with only positive and negative labels. In addition, this dataset is also a very imbalanced dataset from the right figure. I first cleaned the dataset by removing those ambiguous observations, such as records with missing car age despite indicating car ownership or invalid gender in entries. For variables, I filtered out those irrelevant to prediction, recorded certain features into category values, and created interaction terms for enhanced modeling. Finally, all the variables are standardized into either character or numeric formats to ensure consistency. For the model training part, I mainly implemented two different machine learning models on this task, which is logistic regression and light GBM. Generally speaking, logistic regression is a linear model for binary classification that predicts probabilities using a sigmoid function, ideal for interpretable but simpler relationships. And moreover, light GBM is a gradient boosting framework that uses tree-based learning for high accuracy and efficiency, which is beneficial in large dataset and complex patterns. From the experiment results, the ROC curves show that light GBMs achieves a higher AUC than logistic regression on the validation set, suggesting better performance during validation. However, when I submitted for final evaluation on the Kaggle web, logistic regression has higher private and public scores compared to light GBM. I think this indicates that although light GBM performed better during validation, logistic regression generalized better to the test data, possibly due to less overfitting. Moreover, we also visualized the feature importance from these two different methods. That's all. Thanks for listening.